So this is an example of a projectile path problem. It's very similar to the other kinds of projectile problems that we've done, but the equation looks just a little bit different. You'll notice in this problem, here's the equation that models the path of our penny. And let's go ahead and read through the problem to understand it. Jorge threw a penny from the top of a cliff. The path of the penny can be modeled by the equation y equals -1/2 x squared plus 4x plus 180, where x is time in seconds and y is the height of the penny in feet. And it asks us to graph the path of the penny and determine what the y-intercept and x-intercept mean. It also wants us to find the maximum height of the penny and when it reaches that height. And then last but not least, when did it reach the ground at the bottom of a cliff? So to get an idea of what's going on, we could draw a little picture. Here's Jorge, and he's standing on a cliff that is 180 feet in the air. And we know that because of this constant term, 180. And he's going to throw a penny, and it's going to travel a path that looks parabolic. So it's going to go up for a little while, it's going to reach a maximum height, and then it's going to come back down. And at some point, it's going to reach the ground at the bottom of the cliff. And if we graph this equation, we should see this shape right here, and we should be able to determine the maximum at the vertex of the parabola when it reaches the ground right here. And we've already answered the question, what does the y-intercept mean? The y-intercept is where the penny was when Jorge threw it, or at the top of the 180-foot cliff. So let's rewind a little bit. Let's take a look at what it's asking us to do. It says graph the path of the penny. So in order to do that, we're going to use our standard graphing techniques. I'm going to find the vertex using -b over 2a. So that's -4 over 2 times -1/2. And that gives me -4 over -1, or 4. So I know 4 is my axis. The equation of my axis of symmetry is x equals 4. 4 is also the x value of my vertex. So to find the vertex, we would go ahead and substitute 4 into the equation. We'd have -1/2 4 squared plus 4 times 4 plus 180. So 4 squared is 16, right there. And then when I multiply that times -1/2, I get -8. 4 plus 4 is 16, and then I just have this 180. So it looks like 188 is the y value of my vertex. And it looks like I'm going to have a vertex at 4, 188. So let's graph that. Now, one of the things I notice is I need to label my axes, and I need to indicate what kind of scale I have. So I'm graphing time in seconds on the x-axis, and I'm graphing height in feet on the y-axis. So I need to label those. But I also notice that my scale right here won't work. I have 1, 2, 3, 4, and so forth. And I need to graph something that goes up to 188. And that's about 200. So I'm wondering what would happen if I made each one of these marks 20. So this would be 20, 40, 60, 80, and so forth. So there I'm up to 200 and 220, and I'm well beyond what I'm going to need to graph the vertex of my parabola. So let's do 4, and 188 would be approximately there. Now the other thing I know is my y-intercept is 180. How do I know that? Well, if I plug in 0 for x here and here, both of those terms end up becoming 0. So I would have 0 plus 0 plus 180. So my y-intercept is going to be right there, and I know this side of my quadratic is going to look something like that. Now what I need to do is I need to find another point on the parabola to finish graphing it, and that point I'm going to find is going to be the 0. So to make a long story short, I first try to factor this, and I find that it's unfactorable. So I drop back to the quadratic equation, which will work with any quadratic, whether it's factorable or not. So I have negative b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2a. Let me get that underneath the camera for you. So negative b plus or minus b squared minus 4ac all over 2a. Now I've got to simplify the discriminant. So 4 squared is 16. And 4 times 1/2, and it's a negative 1/2, so that would be negative 2 times 180. So that gives me 360 right there. 2 times negative 1/2 is just negative 1. So I add 16 to 360, and I get 376, and then I take the square root of 376. And I get negative 4 plus or minus 19.4 over negative 1. And here's where I split my equation into two. I want to do negative 4 plus 19.4 over negative 1 and negative 4 minus 19.4 over negative 1. So this gives me negative 15.4, and this gives me a positive 23.4. So what this tells me is these are the two zeros of my parabola, my quadratic. And I have a 0 approximately 2123.4, approximately there. So it looks like I would come from my vertex and do that kind of thing to finish graphing my quadratic. I'm not going to worry about this 0, and the reason I'm not going to worry about this 0 is because this is when time is negative. Remember, I'm graphing time on my x-axis, and time can't be negative in this scenario. So I'm not too concerned about where that 0 is. This one, however, tells me that after 23.4 seconds, this is the point, 23.4, 0. After 23.4 seconds, my penny hits the ground. So if I look back at my original picture, that point's right there. So let's go back to the problem, and let's read through the problem a third time and see if we've answered all the questions that we need to. It says, graph the path of the penny and determine the y-intercept and x-intercepts and what they mean. So we already decided we have a y-intercept here when time is 0 and the height is 180. And that tells us that our projectile was thrown or shot off of a platform or cliff that was 180 feet in the air. We've found our x-intercept over here at 23.4, 0. And that tells us that the penny hits the ground after 23.4 seconds. It asks, what is the maximum height of the penny and when does it reach that height? And the answer here is my vertex, which we found was at 4,188. This means after 4 seconds, my penny reached a maximum height of 188 feet. And then it says, when did it reach the ground at the bottom of the cliff? And that we've already answered by talking about our x-intercept, or our 0 right here. So that about does it for the projectile path problem.